velocity with the 0, the antenna was in the bounds of the map. We should do nodes. Interest has to be with a board. Oh man, we got points on this. Okay. That's pretty good. I should have got points on part 1 too, actually. Okay, so kind of an interesting... Actually pretty interesting problem. I like this. Maybe not just because I managed to get leaderboard points on it. But the breakdown of this problem is you're given a grid and everything that's not a period represents an antenna tuned to a specific frequency, so like all the zeros are tuned to the 0 frequency and the A's are A frequency or whatever, and there's different uppercase or lowercase letters or numbers. The important thing to note is if there's 2 antenna in part 1 that are the same frequency, they create an antinode here, which is like take this, go the same distance to the next A, and then plop, there's an antinode, and then also this way, there's an antinode here. The important thing to note is that if there's like 3, it creates, so if there's 2, there's only 2 possible pairwise. But here, these A's create one here, they would create one about here if it were still on the grid. And here they create it on both sides of this, and here they create it on this side, and then if the grid extended further, there'd be one here. So, and this is just telling you that the letters don't matter. If they're uppercase and lowercase, they don't match. So now it's asking how many different locations contain an antinode. So the way I ended up solving this was first loop through, I have a helper to parse the grid into nice point objects that I could do math on. And I loop through the different antenna in the board, and if it's not a period, I add it to this dictionary called ant, I guess. And if we print out ant, let me just remove some of these things. I'm mapping like all the 0 antennas to their different points, all the A antennas to their different points, etc. The next thing to do is you have to iterate through all the permutations of where the antinode would be. So the math there is pretty straightforward. We can use itertool's permutations to loop through all pairwise permutations of it. I realize now the permutations mean that I think I didn't even have to do the reverse here, because it would find like x and y, and then it would find y and x, and it would give me both this location and this location. So basically the math here, because I can do math on these x, y pair coordinates with the class I've defined as a helper, if I want this location, it's the distance between here and here, so this minus this, b minus a, plus b. So it's like this delta plus here, so that's b plus b minus a. Ignore the I part, that's just for part 2. So we go through all the permutations, and then the trick is that might give us locations that are outside of the grid. And so at the very end, I intersected with the set of all the keys that we originally parsed in, which is exactly all the locations that are considered in the grid. So this makes sure we only count antinodes that are in the grid. And then we get our answer. So that's part 1. For part 2, it's basically saying the antenna will like continue creating as far as it can go until you get to the end of the grid. I could have answered this even quicker because I didn't realize where it said the antinode occur at the position of each antenna. So I wasn't counting like, I was only counting these pound symbols here, but not on top of the T's themselves. It's saying this is considered an antinode because it goes here, and this is an antinode because this is on top of this. And actually, I thought that didn't count, so originally my ranges were starting at 1 because I only wanted to add this antinode. But it's a simple change to iterate over, including multiplying the distance delta by 0 gives us this exact antinode. 50 was just the number I chose because I looked at the input and assumed that everything was far enough away that we'd by iterating 50 times we would catch everything. That ended up being very lucky, and I didn't even see 50 here. But we could have ran into a situation where if they were right next to each other and this was bigger, we wouldn't have caught all the anti-nodes. So that was just sheer luck. I guess I should not say did better because I got pretty lucky there. Probably would have also bumped this up to a bigger number if I was getting the wrong answer on the sample inputs. But yeah, that was the answer to part 2. So pretty quick problem. I'm happy that I was able to fight the AI and actually get some points for the day. But yeah, that is